All right, everybody, so this video is just a little bit extra help on 4.5. As I mentioned in class, my son is home with me today because of the smoke. He's taking his nap right now, or he will be taking his nap during class time, I should say, and hopefully he doesn't wake up before class ends. But just in case something goes wrong and he interrupts class, I wanted to put out a little video to help. Don't forget also, there's the screencasts from Dr. Quatrin that are helpful as well. All right, so first question asks us to do some synthetic substitution to find what our value would have been. So I take the value that I want to substitute in. I take my coefficient of x to the fourth, my coefficient of x cubed, my coefficient of x squared, my coefficient of x, and my constant. I bring down my first value, and I know 1 times 3 would get me 3, negative 1 plus 3 would get me 2, 2 times 3 would get me the next value, and negative 1 plus 6 would be 5. 5 times 3 would get me my next value, which is 17. And then 17 times 3 would get me my next value, 51. 51 plus 4 is 55. So I know that f of 3 would have equaled 55. As we would have discussed in class, make sure that you use this notation for your answer. And don't forget, if we were calling this synthetic division, 55 would have been, 55 would have been our remainder. Now, as I would have discussed in class, showing what you're multiplying together is not a necessary step. I'm just doing it to emphasize my work and help you out if you wonder where those values came from. Now, what we'll use this primarily for, though, is to find zeros. And like I would have said, generally I'll give you a zero to begin the problem, because if you're looking it up on your calculator, why not just find the other zeros on your calculator? Now, as we would have talked about in class, if I tell you that something is a factor, when we go to set up our synthetic division, I've got to use the opposite sign, right? If we had factored something and gotten x plus 2, we know negative 2 would have been the 0. And I start taking my coefficients and start my synthetic division. So I drop my first value. Negative 2 times 1 is negative 2, so that gets me negative 6. Negative 6 times negative 2 gets me 12, negative 3 plus 12 gets me 9, and then 9 times negative 2 gets me negative 18. My remainder is 0. Now we should expect that since I told you this is a factor, the remainder would have to be 0. Since we started with a third degree polynomial, I now know that 1 is the coefficient of x squared, negative 6 is the coefficient of x, and 9 is my constant. So I'm left to try and factor the remaining term, which factors into x minus 3 squared, or x minus 3 times x minus 3, doesn't really matter how you list it. So that tells us that we have a double root, or our 0 occurs twice at 3, 0. Now don't be careless, it asks you for the zeros. Don't be careless and forget to give the 0 that you get from the x plus 2. Now, if we had a fourth degree polynomial and we wanted to do this same work, I would need to give you 2 zeros so you can get this value down to a factorable form. Doesn't matter which of those 2 zeros you begin your synthetic division with. It's totally up to you. I'm going to start with 3. I bring down my first term, and I know that 3 times 1 would get me 3. Negative 2 plus 3 would get me 1. I'm doing 3 times 1 again. Gets me 3 again. Negative 8 plus 3 is negative 5. Negative 5, pardon, I'm going to change that. 3 times negative 5 gets me negative 15. 10 minus 15 is negative 5. And then 3 times negative 5 again gets me negative 15, which gets me a remainder of 0. Again, something I would be able to predict because I told you these are zeros. Now, using what would be my new coefficients, I'll set up my next synthetic division, bring down my 1. 1 times negative 1 gets me negative 1. So 1 minus 1 is 0. 0 times negative 1 would get me 0. So I bring down my term, negative 5. And then finally, negative 5 times negative 1 is 5. And as predicted, we get 0. Now, since we started with a fourth degree polynomial and we have done synthetic division twice, I know that 1 is the coefficient of x squared, 0 would have been the coefficient for x, and negative 5 would have been my constant. And even though at first glance it doesn't seem like we can really factor this out, it doesn't change the fact that we can solve and find our two remaining zeros plus or minus root 5. So I know the zeros of my problem, plus or minus root 5, comma 0, 3, comma 0, and negative 1, comma 0. Again, I hope this helps. If you still have some questions, maybe check out some of Dr. Quatron's screencasts. They're linked on our syllabus on the Canvas page. But if all else fails, hopefully we made it through class without my son waking up from his nap. All right, talk to you soon.